Hello, welcome. Continuation of tutorial on coordinate geometry 1. In this episode, we'll be treating how we can find the gradient and the equation of a parallel line. We know parallel lines are two lines that are of equal distance from end to end, meaning they will never meet. They keep on moving on the same tangent, keeping the distance all along. So if we see these two lines, we have the line 1, then the line 2. We want to see how we can find the gradient of these two lines. Now, if these two lines are parallel, then the x-axis become a transverse. A transverse is a line that crosses a parallel line. So if that's a transverse, then the angle produces below the straight line is going to be corresponding. So this angle will be the same as this angle. Now, if you follow from the beginning, our previous episode, we did mention that if I have a line that passes through here, and I have one line drawn parallel to the y-axis and this parallel to the x-axis, producing the angle of 90, making that triangle to be a right angle triangle. If these are the point A and B, we can say that this is going to be the change on the y-axis, because this is parallel to the y-axis. This will be y1, y2. The difference between it will give us the distance here. Then this will also be the change on the x-axis. Now, if I want to find the angle that is here, that angle is going to be having a relation between the opposite side of this triangle and the adjacent side. So, per the properties of trigonometry ratios, we can say that the tan of this angle, which is here, will be equals to the change on the y-axis over the change on the x-axis. Better still, the opposite side over the adjacent. So this is what we have. Then on a plane geometry, the change on the y-axis over the change on the x-axis give us the gradient. So we say that the tan of the angle is nothing but the gradient, right? Good. So if that is the case, then if I want to find the angle itself, the angle itself is going to be the tan inverse of the gradient. Okay, let's hold on to that. So if we are saying that the angle here is equal to the angle here, and the distance between them are the same, parallel lines have the same distance between them, then it means that if I find a line or a distance from the x-axis to this point, which will still be our x, the y-axis change over the x-axis change. Whatever answer I will get for this tan is going to be the gradient, right? It will be having the tan inverse of the gradient. This very angle will be the tan inverse of the gradient. Then, this angle also, if I draw it, forming a right angle triangle. Imagine we are saying that this tan is going to be equals to the tan inverse of gradient. So I have to put the same value. If this is 40, this is 40. Then the tan gradient of the gradient, the tan inverse of the gradient will also be the change on the y-axis over the change on the x-axis. Meaning this angle will also be having the opposite side to be the same as this and this. Then the adjacent side will also be the change on the x-axis. So all that I'm trying to say is that if we check carefully, the gradient of this line 1 will end up being the gradient of this line 2. See, it's the same change on the y-axis over the change on the x-axis. That is what we are putting to find the angle, which are both equal. So on general perspective, any two lines that are parallel have the same gradient. That's what we are trying to put across. That any two lines, two or more lines, whatever they are. So by pairing, if we say they are parallel, it means their gradients are going to be the same. So that simply means that if I know the gradient of the line 1, I can find the equation of the line 2, meaning they are the same gradient. So I only use the gradient and any point on the line to find the equation. So we are going to see how we can apply this in solving some kind of questions that have parallel lines in its framework. Okay, so let's look at this. We have to find the equation of a line which passes through the point 1, 3 and parallel to this equation. It means this is the equation of one of the line. Then we are asked to find the equation of the other one, which is passing through the point 1 and 3. So we have already established that if two lines are parallel, then so if the two lines are parallel, then it means they have the same gradient. So now we are going to find the gradient of the first one. So 2y minus 3x plus 2 equals to 0. Remember the previous episode, we've learned how to find the equation of this directly without writing it into the slope-intercept form. But we can still write it in that form. So here, if you want to find the slope, it's just going to be negative a over what? B. And what is the a? The a is the coefficient of 3, of x. Then b is the coefficient of what? Y. So I'll be having negative 3 out of what? 2. And that will give us 3 out of 2. If you don't want to use this, you can also rewrite this in the slope-intercept form, making y the subject. All right. So now, so we can say that this is the gradient of the line that we have been given, which is said to be parallel to the line that we are looking for. Therefore, the gradient of the new line is going to be 3 on 2. They have the same gradient. Therefore, the equation of the line is going to be given as y minus y1 mx minus x1, which passes through the point 1 and what? 3. So what are we going to do? We are only going to do substitution. The m will take this, the y will take this, and the x will take this. So I'll be having, it implies that y minus 3 equals to 3 on 2 x minus 1. In this form, we multiply by 3 since we are having a fraction with by 2. A fraction with a denominator of 2. So 2 times this, 2y, 2 times 3, 6. When 2 multiply here, you'll be left with 3, then x minus what? 1. Let's open the bracket. 3x, 3 times 1, minus 3. So now let's transpose everything from the left to the right. We'll be maintaining this one since they're already in the right. So I have my 3x. Then let's bring minus 2y minus 3 plus 6 equals to 0. Let's compute the other end here. I'll be having 3x minus 2y, negative 3 plus 6 will give you positive 3 equals to 0. So writing this in the general form, this will give us 3x minus 2y plus 3 equals 0. We can also write this in the slope-intercept form, which will still be the same equation. So I'm sure the concept of gradient of a parallel line and its equations are okay. All right, thanks for watching. Like, share, and comment. Bye-bye.